How much heat is needed to convert 50.0 grams of H2O from 70 degrees Celsius to steam at 110 degrees Celsius? Whenever you're given this type of problem, you have to know and you have to familiarize and memorize how to use these values, these conversion factors, and we'll get to that in a minute. So just to put these in view, you use ice, or you use 2.1 whenever you're here at 0 degrees Celsius. Okay, so you'll use 2.1, here, let me rewrite that. You will use 2.1 whenever you're here. And a way to memorize that is ice, that letter I looks like 1. So you can associate that with ice. And the next, water. Water, you will have to memorize. You use water in between 0 and 100. So you will use water right here, 4.18. And at the very top, steam. Okay, so steam you'll use 2.0. And steam, you associate steam and with bubbles. And so the 0 looks like a bubble. That's how you can memorize this. And these values right here, you can look at it as something separate. Okay, you will use these on your flat lines. Okay, these are your flat lines, and you'll use these values whenever you are traveling on these flat lines, and we'll see how to do that. Okay, so once again, whenever you are on flat lines, you will use the equation Q equals MCAT. Whenever you are on flat lines, you will use dimensional analysis with these values here, okay? So just to label this, make it easy, this is ice, okay? This section right here is ice. This section right here is water. And at the very top here is gas, okay? So the next step that I like to do, that I encourage you to do as well, is to map out your equation. So you're given 70 degrees Celsius, okay? This is where you're starting. So you're starting here at 70. And then the next step is to map out how you're going to travel up to your destination, which is 110, which is right here, okay? And to do that, you're going to go you start at 70, okay, which means you're going to have to travel up a diagonal, use a flat line, and then go up one more time to get to 110 degrees Celsius. So we're going to put these 3 steps, okay, into equations. So first, map out your first step, your first travel path, okay? 1. So we're using a diagonal. We're traveling up a diagonal to get to 100. So to do that, you'll use an equation. You'll use your Q equals MCAT. So Q is equal to your mass, which is 50.0. It's given to us in the problem. And you will use what we have. So C, which is your C value, is 4.18. This is where you're using, these are where these conversion factors come in. So you'll use 4.18, okay? And then your last thing, the AT, or the triangle T, refers to your temperature change. So how much does it take? How much temperature does it take to go from 70 to 100, okay? 100 minus 70 is equal to 30, and you simply put that there. Okay, once you do that and you plug that into a calculator, it will spit out 6,280 joules. And a next step, if it's required, you will convert it to kilojoules. So 1,000 joules is equal to 1 kilojoule, okay? And you will get 6.28 kilojoules. Okay, what we did right there is was our first step here. Okay, this green path, that was number 1. Okay, and then now we have to do this path. Okay, we have to travel by flat line. 2, and to use these to use these flat lines, this red line that I marked are your flat lines. You have to use either one of these, okay? And I'll explain how to use these. Okay, so vaporization is up top, okay? Vapor, because you are going from water to steam, it's vaporizing. And fusion is what you will use to go from water to ice. Okay, so we're not going to use fusion right now. We're solely focused on vaporization because it's asking us to go to steam. Okay, so we will use this value and we will do a form of dimensional analysis. So in dimensional analysis, start with your given. Start with what you're given, 50.0 grams of H2O. And we're going to convert this, okay? Whenever you look at the periodic table, hydrogen is 1.01 and oxygen is 16.0. So when you add those two values, you have two hydrogens, so 1.01 plus 1.01 plus 16.0 will give you a total of 18.02 grams of H2O. From here, you can use a mole to gram conversion. So now you can easily change that to moles. And here we are at moles now. So where else do we see moles? We see moles at our vapor, okay? We have kilojoules per mole. So you can drop down your mole. And now you use the value 40.07. Oh, 40.7, excuse me. Kilojoules, okay? And whenever you plug this into a calculator, 50.0 times 40.7 divided by 18.02, you will get 113 kilojoules, okay? Round to 3 sig figs because your given has 3 sig figs here. Okay? And now look, we are halfway done. We're not even halfway, we're 75% done already. We have our two values in kilojoules, and now we need to do the last step. Okay, the very last step. Now we are at step 3, our last step. Now we are at 100 degrees of water. Okay, now we need to, we are at 100 degrees steam. Now we need to change 100 degrees steam to 110 degrees, to 110 degrees steam. And we will do the same thing as the first step. So you go to Q equals 50.0 grams of water. But now here's the this is very important. Your C value, it's different now, okay? We are not at water anymore. We are now at gas, okay? We are at steam, so we have to use 2.0 now. Okay, so 2.0 is going to be our C value in our Q equals MCAT equation. Okay, this is very important. Now, this is and also another key that a lot of people mess up on. To go from 100 to 110, it's just 10, okay? Don't put the whole thing. Don't subtract 110 from 70. Don't confuse yourself. Just go step by step. And 110 minus 100 is equal to 10, okay? And whenever you plug that in, you will get 1.01 kilojoules. Okay, you will get 1.01. You'll get joules, okay? And then whenever you convert that, like how we did up here, you'll get 1.01 kilojoules. So just make sure you convert your joules to kilojoules, because Q equals MCAT will give you your value in joules, okay? So now it's asking us to find how much heat is needed, the total heat. You add these three values, okay, 6.28 plus 113 plus 1.01, okay, and that will give you a total of 120.29 kilojoules total. So this right here is your answer. You are done. Okay, let's try another problem. How much heat is needed to convert 100 grams of ice at -5 degrees Celsius to water at 85 degrees Celsius? Okay, like the last problem, let's map out, okay? So it's asking us to go from -5 to 85. Okay, so it wants us to go from ice to water. Okay, so let's map out our path. So -5 to 0, okay, and then from ice to water, and then from there up to 85. Okay, so we're going to do diagonal, flat, diagonal. Okay, now let's turn these green lines here into equations. So step one, we are traveling diagonally, so every time you go diagonally you will use the equation Q equals MCAT. So your mass 100 grams. Your C value, okay, this is important. We are at ice right now, okay? From 0 down below is ice, from 0 to 100 is water, and from 100 up is gas. We are right now at ice, so whenever you're at ice here, okay, whenever you're at ice, you will use 2.1. Okay? And then simply our temperature change, our triangle T, to go from -5 to 0 is 5. 0 minus -5 is 5. And I'm going to keep it in joules this time. And when you plug that in into a calculator, you'll get 1050 joules. Okay. And we just completed step 1, path number 1. Okay, that was number 1. Now we need to go to number 2. So we'll plug in 2 here. Okay, we are at this point right now. We just went from here to here, and now we need to travel flat. We need to go by a flat line. Okay, we are traveling on a flat line now. So whenever you do that, we will do dimensional analysis. Okay, always start with your given 100.0 grams of H2O, and that on the periodic table H2O, it's going to be 18.02 grams. And simply we can use a mole to gram conversion. And where else do we see moles? We see moles here, okay? Whenever you are traveling on flat lines, remember to only use these two, okay? These are for flat lines. Now we are going from we aren't going to gas, so we won't be needing vapor, okay, in this problem. We just have to use fusion, okay? Just know that whenever you're down below, you will use 6.01. And if you're doing any problems like the last problem up top, you will use 40.7, okay? But we don't need 40.7, so just disregard that. And back to the problem. Okay, 1 mole, you drop that down, 1 mole is equal to it's equal to 6.01 kilojoules, okay? And I'm just going to take the extra step and and convert that to joules, because that's what we have here. So 1 kilojoule is equal to 1,000 joules, and then you will get 3,335 joules. Okay, now we are almost done. We have one more step. Okay, that was step 2. Now we have to do step 3. Okay, go from here up to 85. Okay, we are traveling diagonally, so once again, whenever you are traveling diagonally, you will use Q equals MCAT, so 100.0 grams. Okay, but wait now, it's not 2.1, it's not 2.0, okay, we are at water. Okay, we are at water now because we're up here. The section from 0 to 100 is water, so we will use this value for our C, 4.18, and our temperature change to go from 0 to 85 is 85. Okay, 85 minus 0 is 85. And when you plug that into the calculator, you will get 35530 joules. Okay. And now, whenever you're doing that, you're done. Now you just add these values up, and then you will have your final answer.